So a projectile is launched from a 45-meter high cliff, continuing from yesterday. Dolp. There's my cliff. I drew it fairly big-ish on my screen. What's its height? Oh, 45. It's launched at an angle. I drew mine pretty big, even going through the question itself, because I just wanted to see a nice big triangle. At an angle of 64 degrees with the horizontal. And this velocity here is 36 meters per second. Carter, am I going to use that 36 in my work at all later on? No. I'm going to oh, did I say angle? I'm going to do components. And then I'm never going to use that 36 again. So I'll do my t-table right here. You can stay organized however you want. I find a t-table is a minimum amount of work, but that little wall running down the middle just helps reinforce. Don't you dare put a horizontal into a vertical. Don't you dare put a vertical into a horizontal. What are my two physics no-brainers? Yep. And AY, negative 9.8. So I'm going to break this up into its components. There's Vx. There's Vy initial. Why did I put an initial on the Vy, but not bother putting one on the Vx? Because Ax is 0, so Vx initial is Vx final, is Vx is not changing. Vy is the one that's changing. That's why I put an initial, knowing it's going to change. Vy. Sine? Yeah? That was our dumb little hack. And again, if you forget that stupid trick, go ahead. It's opposite, it's hypotenuse, and hopefully a clue. That's sine. But if you're looking for a shortcut, we can say this. Vy initial is what times what? Loud and proud. 36 sine 64, yes? Which is, I have no idea. Does anybody here have a graphing calculator, like a TI, like the one I have on my screen? No, I'm just at, the reason I ask is I know the TIs, if they reset, they automatically default to radians instead of degrees. If you're doing homework this year in physics and you're getting stupid, wrong, bizarre answers, especially weird negative answers, double check your angles. You might have accidentally reset your calculator and it might have defaulted to radians rather than degrees, okay? So if I'd gotten negative something here, I would have panicked. No, I would have said, oh, mode, oh, radians is highlighted. I reset my calculator. Better go back to degrees, okay? 32.356. 32.3566. 32.3566. Vx, of course it is. I said I wasn't going to walk you through it, so now I'm going to shut up. Try continuing on your own. really running out of room here. Yep. Yep. Okay, I need more room, so let's cheat. I can do this. And I can do this. And I can do this. I love digital ink. Then I can do this. Whew, now I got room. Sean, did you use the solver? Oh, you did it a long way? Anybody have a solver? Use the solver for the quadratic? What'd you get for the first time value on your solver? 7.7833. So we're both good to 5 sig figs, either method? Good enough. Negative 1.7. Oh. Nice. If you got this, this is one kids in previous years have really struggled with. So I don't know what's happening this year, but you folks are doing better than average on this particular question, which I like. Lots of room to make typos. I caught myself. I was partway through and I suddenly realized that right here, I'd written a 5 instead of a 3, and I was already on this next line. I went back and had to fix it. So you just kind of really got to be meticulous and careful and keep moving your eyes back and forth and double check and triple check. And okay, you still got time if you need it. Those of you with the built-in solver, though, are sitting smugly because you probably finished a while ago. Poor Nick is having to type like mad. Oh, did you forget to make it negative?
No, I was using the last question as an example.
Oh, and you copied things over and forgot to swap the numbers? Yeah, that happens. But by the way, Wes, the other risk is if you forget to make this negative, you probably will get a value for time in your quadratic equation. Last year, we always got an error on our calculator. These ones are complicated enough because there's two answers for time, one positive and one negative. You probably will get a positive answer for time and not catch that you've made a typo. That's the other reason these are so challenging. Where last year, when you missed the negative, you ended up trying to take the square root of a negative and you always got an error. Not necessarily this time. Sometimes. Depends on what numbers I use. Everybody done? How many of you got that okay? Nice. What else can we do? Well, B. At what time does the projectile reach its maximum height? So now turn the page. At what time does the projectile reach its maximum height? What's this question asking me to find? Be obvious. Time. Okay, but not the 7 point whatever we just found. Time to the top. Maximum height. Does that sound vertical or horizontal to you? I'm not going to do a full t-table, but I'm just imagine I'm only putting the vertical stuff here. With me? So I'm going to fall back because I'm not sure how to do this on my, well, t equals question mark. And I'm going to write what I know vertically. So I'll scroll back. Folks, can you all write AY equals negative 9.8? And you can also write VY initial equals 32.3566. Would I write DY equals negative 45? I don't think we're at the bottom yet. We're at the top. So this piece of information is not going to be valid. But these first two, AY is negative 9.8 and VY initial 32.3566. Let's see. AY negative 9.8, V initial 32.3566. That's two things. I need three things to find the fourth. What else do I know? What's VY final? Oh, so I can use that. Not at the bottom. Do a belly flop on the cement and you'll find it's not zero. But at the top, sure. So VY final is zero. So how could I find time? Thankfully, not with the quadratic formula. Looking for an equation that has a T, an A, a VI, and a VF in it. It's our old friend. Yeah. VF equals VI plus AT. T equals VF minus VI over A. Double check. Vertical, vertical, vertical. I'm good. I'm not putting a horizontal into a vertical. Common mistakes. Everybody look up for a second. People forget the zero, but they know they need a velocity. So they'll often pull this one in, the 36, the slanty that I've told you never to use, or they'll make that V initial, and they'll make V final the 32.356 or something. So don't do that. Okay. 0 minus 32.3566 over negative 9.8. I didn't really leave you enough room here. I need to retype these and give more room. You get a time to the top of 3.3017. .3 is probably what I'd say in my answer, but I'll carry the extra sig figs because there was a part B. How high is the maximum height? What are they asking me to find there? I can either use dy equals vy initial t plus a half ay t squared. I'll be using this time value that I just calculated, but I think I told you this year I'm not scared to use an answer to find an answer. I'm just going to be efficient. I could also use vf squared equals vi squared plus 2ad, and I could solve that one for d. But since I have time sitting on my calculator right now, and the d is already by itself here, I think I'd use this. I didn't leave you enough room, so we're going to go straight to typing in the numbers. Vy initial was 32.3566 3566 times answer button plus 0.5 times negative 9.8 times answer button squared. And I get 53.4. Why does the answer say 98.4 and not 53.4? McKenna, what? The height of the cliff. Yeah, what we've just found is how high above. Remember, we're finding displacements. We found how high above where we started. But we didn't start on the ground. Okay? So I would say this. Height. Oh, what would be a good letter to use as an abbreviation for height? H, you say? Equals 53.4 plus 40. And that's where the 93.4 meters came, or 98.4. 58, 53.4, 58 point, no, 53.4. Oh, the original height was 45, was it? 98.4. So question C, I used to ask something like this either as my nasty multiple choice, and I might, but I'm not going to make this a written this year. So finding a slanty velocity. I want you to find the velocity, Noah, when? At t equals 2.4 seconds. Hey, Noah, how long did it take us to reach the top? Good, remember that. Normally, when we found an impact velocity, I've done this, don't write that down, and then I've gone d. How long did it take us to reach the top? What's the time here? I think we're still on our way up. So instead of, I think I'm going to say, I'll bet you this velocity looks something like that. At an angle. Did I say angle? You don't say. So this is the velocity that they want me to find. Okay. By the way, I yelled at you a little bit last day, put arrows on your vectors. It really helps you see how the diagrams fit together. Oh, I'm going to the right and I'm going up. That's the same as slanty up and right. If you don't put the arrows there, it's way harder to figure out, well, where's the vector coming from? By the way, where am I going to put the theta? Bottom left or top right? Darn right, bottom left, because that's where the vector is coming from. And this is Vx, and this is Vy, not initial, final. By final, I mean at 2.4 seconds. Oh, I know one of these already, because Vx never changes. It was, I'll scroll back for you, 15.7814. Well, I know that AY was negative 9.8. VY initial was 32.3566. Ooh! And T is 2.4. And I'm going to use VF equals VI plus AT. But I'm going to put all verticals into there, except time, which is a scalar. So if I do that, oh, I should get a positive answer this time because I think I'm on my way up. Now, Noah, if I hadn't done part B, if I didn't know that it was 3.3 seconds to the top, if I had guessed that wrongly and I got a positive answer, I would probably just quickly scribble it out, do that, and there, now it's fixed. Or I could figure out if I'm at the top or not by letting Vy final equals 0, solving for T the same way we did here, and then I know, am I on my way up or on my way down? I sometimes do that. Sometimes I'm lazy, or sometimes, oh, the time is really big. I'm pretty sure we're on our way down. Oh, we're only 1 second after launch. We're probably still on our way up. Does that make sense? Okay. V final for vertical is going to be 32.3566 plus negative 9.8 times 2.4. Give me a positive answer. 8.83. Barely still on our way up. We've slowed down, but we're still on our way up. 8.8366. Okay. How will I find the magnitude? Pythagoras? Are we starting to notice, Karn, it's getting repetitive? We're using really 4 tools. SOHCAHTOA, Pythagoras, components, and tip to tail. Oh, I guess the quadratic formula once in a while. That squared plus 15.7814 squared. What? Oh, square root, Mr. Duke. Don't forget the square root. 18.1. Color. Opposite, adjacent. Tan again? Yeah. Oh, cool. I think I made a typo. Yeah, I missed the 1. 7, 8, 1, 4. 29 degrees? 29.2, 29 degrees? And this is where we said we call, because we're looking at it from the side, we call this above the horizontal. So this question, part C, to me, fair game for a take-home quiz, but I don't think this year I'm going to hit you with it on a test. Okay. Is there a part D? That's about what I can kind of ask. I guess, okay. I could have asked you what the horizontal distance is after 2.4 seconds. How far sideways has it traveled? Oh, that would just be dx equals vxt, 15.7814 times 2.4. Not a quadratic. We did this, we paused here. What's 6a asking us to find? A slanty velocity? Did we just find a slanty velocity? Yeah? So, first of all, 6a, do you see an angle? We're launched from the ground. I would break that into its components. Vx is not going to change. After 4.6 seconds, I might let Vy final be 0 to figure out, am I on my way up or on my way down? So I would know whether to draw that or draw that. But then, since it's at an angle, did I say angle? I would go d. I would fill in Vx. I would solve for Vy final, and then Pythagoras and trig. We just did one like that. So I'm not going to do another one. So it says pause here. A and B are really the same question. Okay. So I had assigned number 1. I assigned number 3. If you want a practice velocity question just because they're tricky, you can try number 4. Oh, no, I don't like that. Never mind. I take that back. Don't like number 5. No, actually, I don't like those ones. Okay. From the ultimate review, can you get out that big, thick, massive ultimate review that I gave you? Okay. I made these back when the provincial exam existed and I had to cover every single detail. This year, with the quarterly system, and I'm not seeing you as often, I'm not going to cover every single detail. So there's going to be some questions I'm going to cross off. Remember, I've put a full showing all my steps handwritten answer key on my website. What's my website? pitmath.com. If you go there, click on Physics 12, click here for today's notes, and go to Block D, Unit 1, Kinematics. You'll see there's a PDF file where I showed all my steps. I like 1 is fine. You should know the difference between vectors and scalars. So 1 is good. 2 is good because it's asking you to find components. I like 3. 3 is fine. I like 3. 3 is fine. I like number 4. I like number 4. I like number 4. Number 4 is a nice question. Five, meh. I'm not saying don't do it. I'm saying meh. There it's asking you to find the height 17 seconds after launch. I'd probably just ask you to find the maximum height. But they gave you the time, t equals 17. You would go, you could do it, but yeah, it's asking you to find a dy. So you know what? I'll do you a favor because we're cutting corners. You can cross out 5. 6 is good. So take a look at number 7. This is an example of a using principles of physics question. Sorry, I'll wait till you're with me. Back with me now, Sean? Because I'm explaining stuff about the test, so you might want to pay attention, just saying. Okay. Look at number 7. This is an example of a using principles of physics right to explain question. These were on every provincial exam. It was the last question on every provincial exam. There's going to be one of these on every one of your tests. They're going to get progressively more difficult, but there's going to be a question where I ask you to convince me of something or prove to me something, and I'll mark them fairly easily and leniently. So number 7 here is kind of vague. It says this motion can be analyzed in terms of horizontal and vertical velocity components. Explain the behavior of these velocity components using principles of physics. What can you tell me about Vx? Constant. I would give you 2 marks for this question because it's out of 4 for saying that. What can you tell me about Vy? Changing. There. What can you tell me about Ax? 0. What can you tell me about Ay? So if I'd ask you to talk about the acceleration components, there. Okay? Later on, as we get progressively more challenging, you'll see questions like, oh, suppose we double the launch speed. Now what will the orbital radius of the satellite be? Or suppose we reduce the mass. Will the new radius be smaller, bigger, or the same? We'll be doing stuff like that, and you can always make up reasonable numbers and just crunch the answer to see what would work. We did do one using principles of physics thought puzzle with the question where we asked, are we going twice as fast, more than twice as fast, faster, but not more than twice as fast? Sure, 8 is fine. 8 is physics 11 because there's no slanty, it's straight up and down. Nine is okay. Part B, which the letter B somehow got chopped off. Fair game for a quiz because you're going to find a slanty velocity. I'm not going to ask you to find the slanty velocity on the written section of the test. You can cross out 10. 11 is good. 12 is good. I like 12. I like number 13. I like number 13. I like number 13. Here's a nice boat river question or airplane. There is going to be, I'll be more specific. Your test is going to have 4 written questions. One is going to be either airplane in a crosswind or boat river. One is going to be cliff at an angle. One is going to be ground at an angle. One is going to be horizontally from a cliff. So I like number 13. 14 is good. I like number 15. There's your airplane in a crosswind question. 16 is good. I like number 17. I like number 17. I like number 17. I like number 17. What's number 17 asking you to find? What's changing anything? If I'm going to get you to do some vector subtraction, it's probably going to be a change in question. Just saying. You can scratch 18. 19's fine. Don't like 20. Cross out 20. $21 is okay. Oh yeah, it's asking you to find V final. Never mind, that's fine. I think in 21, you can't find V final right away. You'll have to find A first and then find V final. Unless you remember that one from last year that had the VI and VF in brackets, but it's redundant. I didn't give it to you on your formula sheet this year because find A and then you got V final, just fine. I like 22, I like 22, I like 22. 23 is good. I like 24, so there's someone swimming in a river. Here's a horizontally from a cliff. Okay. This one's a little bit easier. Instead of giving you the height of the cliff, they've given you the range, dx. So when you make your t-table, you'll have a dx, which I think usually means you don't have a quadratic to deal with and makes things much nicer. Find time and then find the height. 26 is good. 27 is good. 28 is good. 29 is good. 30 is good. Oh, 31 is fine. 31's going to fall apart. Do you know how I can tell 31's going to fall apart? They gave me time, which means I got t in both columns. They want me to find the height and the range. Easy peasy. Make your t-table components, but then you should find, oh, I got 3 things in each column. I can find d. No problem. 32 you can cross out. 33 is cool. It's a scholarship question, though. You can cross out 34. 35 is nasty. They used to do this on the provincial all the time. This was asking you to find an impact velocity when it hit the wall. It was NOAA asking you to find a slanty velocity. It was giving you enough information to do that, but I'm going to say you guys can pass on it this year. You can try it if you're like, hey, I want to really nerd out on this. Look at my answer key, see if you can get it right, but I'm not going to ask you that one. Scholarship question, you can skip this one as well. But 37, you're going to get one like 37 on your test. Cliff at an angle, find the range. So I like 37. 38, find the impact velocity. You can skip this one if you want. 39, you're going to find one like 39 on your test. Cliff at an angle, find the range. And then there's the answers there. And I've shown a full handwritten showing all my steps answer key. Okay? That brings us to the end of the unit. I have a take-home quiz for you to work on. So let me hand that out.